All right, in this video, let's take a look at two examples of solving variables on both sides equation. The first one that we're going to look at is this equation, 11 plus 2p is equal to p plus 4. And the first thing you should notice is that your variable in this equation is p, and that's what we're going to end up solving for, okay? To start with, make sure you draw your line down the center of the equal sign, so you've got the left side and the right side of the equation. And to begin with, we're gonna start with isolating the variable p on one side. Okay, so if we're solving for p, we gotta make sure that that variable's on one side of the equation so that we can ultimately solve our problem. There are two variables on the left side. We've got 2p on the right. We've got 1p, and we want to eliminate the smaller valued variable term, okay? So to do that, we're going to eliminate the 1p on the right side of the equation, and we can do that by subtracting 1p from both sides, okay? When you do that, that eliminates that term. On the right, you're left with a positive 4, okay? On the left side, if you subtract 1p from 2p, you have a positive 1p left over, and you've got 11 plus 1p, okay? All right, again, we're trying to solve for 1p. Now we've just got a simple two-step equation that we solved previously. If we're solving for our variable, we want to eliminate any other constant on the left side, okay? So we're going to eliminate 11 by subtracting it. Okay, that way you've got 1p left over on the left side. On the right side, 4 minus 11, it'll have negative 7 left over. Okay, and that's your solution. P should be equal to negative 7. Okay, let's take a look at one other variables on both sides problem. And this is going to be example 2. This equation, on the left side, we've got 3 times our variable r plus 1 plus 5, and that's equal to a negative 6 minus 1r on the right side. Okay, again, start by drawing the line down from the equal sign and separating the left and right side of the equation. This looks a lot like our previous example, except for an additional term on the left side. Okay, and we have two constants, a positive 1 and a positive 5, and those two constants we can just combine together, okay, because those are like terms. So when you do that, positive 1, and if we add 5 to it, on the left side we'll get 3r plus 6, okay, and that should be equal to what's left over on the right side of the equation, okay. So really we just did a preliminary step of simplifying our equation a little bit, combining the like terms, okay. And now what you've got in example 2 is a variables on both sides problem like the first example. Again, we're going to start by eliminating the smaller valued variable term, okay, which is the negative 1r on the right side of the equation. Okay, so to eliminate it, we'll use the inverse. We'll add 1r to both sides. Okay. When you do that, 3r plus 1r on the left side, you've got 4r as your variable term, plus 6, and that's going to be equal to a negative 6 on the right. Okay, we're trying to solve for r, so again, we want to isolate it and eliminate any constant on that left side of the equation. Okay, so we can subtract 6 from both sides, and that eliminates the constant term on the left. All right, then you're left with 4r on the left. On the right side of the equation, negative 6 minus 6 ends up giving you a negative 12. Okay, so it gets a little bit more negative when you subtract something from a negative number. And finally, we can solve our equation for r by dividing out by our coefficient. Okay, so we're dividing by 4 on both sides of the equation. That eliminates your coefficient on the left side, and you just have r. Okay, on the right, a negative 12 divided by 4. That division gives you a negative 3 as your result. Okay, so that's your solution. R is going to be equal to negative 3 for example 2.